Good afternoon. Today we are going to see the problems from exercise 2 which are on combined loading. We have first problem, that is imaginary pier 3 meter by 4 meter supports a load of 60 kilonewton as shown in figure. Find the stresses developed at each corner. So we have that four corners, one, two, three, four, and we are interested to determine the stresses at this corner, and this is our P acting at this point, which is 60 kilonewton. Now we will first write down the given data. So we have given data. So we have given P is equal to 60 kilonewton. Then Ex is given. So this we are going to say XX axis. So we have Ex zero point 0.5 and Ey 1 meter. So Ex equal to zero point 0.5 meters. Ey we have 1 meter. Now we will find A, which will be equal to 4 into 3, which will be 12 meters square. Then we will calculate Ix about XX axis. So we have 4 into 3 cube upon 12. It comes 9 meters square. Then we have Iyy, which will be equal to 3 into 4 cube by 12. It comes 16 meters square. Then we will calculate Zxx, which will be Ixx upon x by 2, or Ixx upon x, which will be 9 divided by 3 by 2, and that will be 6 meter cube. And Zy we will get equal to Iyy upon y, and that is equal to 16 divided by 4 by 2, and that is equal to 8 meter cube. So we have Zxx 6, Zyy 8 meter cube. Now we will find sigma d, that is equal to direct stress P by A. P we have 60 and A we have here 12 meters square. And from this we will get 5 kilonewton per meter square. Then we will go sigma bx, which will be mx divided by zx. Mx we have p into ex, so we have 60 into ex we have zero point 0.5, and zx we have 6. So it comes 5 kilonewton per meter square. And then we have sigma by, which is equal to my upon zyy, and we will have my, that is 60 into 1, and zyy we have 8, and from this we will get value as 7.5 kilonewton per meter square. Now we have four corners. So if we will write first sigma 1, then we have here sigma d we have plus. I will write all. Then we have sigma 2. Sigma d is here also plus. Then I will write sigma 3. Sigma d we have plus everywhere. And then we have sigma 4. That is direct stress. We have always plus. Now we are interested with sigma bx. Now we have column that is above this axis. So 1 and 2 we have plus due to bx. and 3 and 4 are minus due to bx. So we have plus sigma bx plus sigma bx, and then we have minus sigma bx, and then minus sigma bx. Now why we have 1 meter on this side, so we have sigma by plus on this side, sigma by plus on this side, minus here, minus here. So we have 1 minus sigma by, then 2 plus sigma by, 3 plus sigma, sorry, 3 we have minus sigma by, and 4 we have plus sigma by. And then if we will put values in this, then from this we are going to get, therefore sigma 1 we are going to get it as, so we have 5, so I will write 5, then plus here I will write 5 plus sigma bx 5 minus 7.5, and we will get sigma 1 that is equal to 2.5 kilonewton per meter square, that is compression. Then we have, this is 5, then sigma bx also 5, and sigma by plus, and then this will gives us value that is equal to 12.5 kilonewton per meter square. So sigma 2 12.5 kilonewton per meter square, again compression. Then sigma 3 if we will go, 5 minus 5 minus 7.5, which will be equal to minus 7.5 kilonewton per meter square. So we have sigma 3 7.5 kilonewton per meter square, but it is tensile. And then sigma 4 we have 5 minus 5 plus 7.5, and it will be plus 7.5 kilonewton per meter square. And the sigma 4 we have 7.5 kilonewton per meter square, that is compression. So likewise we will get values of stresses at all corners. Then we have second problem. So this data is given, and then again what additional we have given. So we are with only this part, this we are not going to solve it. So given data, and then we have this will be equal to P equal to 315 kilonewtons. Then we have Ex, now we have this as Xx, and then we have this as Yy. Then we have Ex, that is equal to 30 millimeters. Ey we have 10 millimeters, sorry, 20 millimeters. This 10 millimeter we have thickness of web. This is Ey, and this is Ex. Now we can find area of this, which will be equal to 160 into 15 into 2, because we have two flanges 1 and 2, and plus web we have 150 into 10, and we will get this total area that is equal to 6300 millimeter square. Then we will find Ixx. So we will have 160 into 180 cube by 12 minus 150 into 150 cube by 12, and that value we will get it as 35.57 into 10 raised to 6 millimeter to the power 4. Then if we will calculate ZXX, then we have 35.57 into 10 raised to 6. Now for axis XX, we have Y as 90 and ZXX is 395.22 into 10 raised to 3 millimeter cube. Then we will have Iyy is equal to 2 times B we have 15, D we have 160 cube by 12 plus B we have 150 into 10 cube by 12. And we will have Iyy is equal to 10.25 into 10 raised to 6 millimeter to the power 4. And from this we will get ZYY is equal to Iyy by y, and that is equal to 10.25 into 10 raised to 6 divided by we have 80. And from this we will get 128.16 into 10 raised to 3 millimeter cube. So now once we have these values and we know P, we know E, then we can find sigma D, which is equal to P by A. P we have 315 into 10 raised to 3 and A we have 6300, and from this we will get value as 50 MPa. Then we can have sigma Bx is equal to mx by zxx. Mx we have 315 into 10 raised to 3 into ex upon zxx we have 395.22 into 10 raised to 3, and we have sigma bx that is equal to 23.91 MPa. And third we have sigma by, which will be equal to my upon zyy, and that is equal to 315 into 10 raised to 3 into 20 divided by zyy we have 128.16 into 10 raised to 3, and then we will get this value as 49.16 MPa. Now you can see for A we have sigma D plus, other two we have minus, or we will go one by one. So we have sigma A, then we have sigma B, then sigma C, and then sigma D. Now sigma D we have plus in all. So sigma D we have plus. Then we will go to sigma Bx. Then we can see. So sigma Bx. So we have on this side. So D and C will be plus. AB will be minus. So AB we have minus. So minus sigma Bx minus sigma bx, then we have plus sigma bx, and then we have plus sigma bx. Now due to y, we have y on this side, and therefore we have a and d as minus and bc plus a d minus. So we have A and D minus. So A and D we have minus, and then these two we have, that is B and C, we have plus. And now we will put the values. So we have 50 minus 23.91 minus 49.16, which will gives us value as 23.07 MPa, and that will be tensile. Then we have second, that is 50 minus 23.91 plus 49.16, and that will be equal to 75.25 MPa, and we have this as compression. Then we have all plus 50 plus 23.91 plus 49.16, which will be equal to 123.07 MPa. Again we have this as compression. And third we have 50 plus 23.91 minus 49.16, and that will be equal to 24.75 MPa, and that is again compression. So we have these problems which are related with your mm, exercise 3. So we will stop here only. So thank you.